Okay, in this video I'm going to go ahead and give it my best attempt to explain the imaginary unit. My goal is to really explain the imaginary unit so I can explain the complex number, so I can go ahead and explain a mathematical problem to my to a friend of mine. Alright, so basically I'm going to go ahead and start this off. Okay, so we let's say we have let's just start off with the idea of squaring. So I have 1 squared. Well, that's just equal to 1 times 1. Well, same idea. 2 squared. That's just equal to 2 times 2. Well, that's just going to equal 4. That's just going to equal 1. 3 squared. That's equal to 3 times 3, and that's just going to equal 9. All right, fair enough. But let's say I was just given the number 9, and I was told to find what number times itself will equal 9, or I was told to find the square root of 9. Well, that would just be 3, because 3 times 3 equals 9. It's as simple as that. That's just the idea of a square root. What number times itself will equal a 9? Now I wanted to go back to the idea of squaring and go ahead and say something else real quick. I only did positive numbers, but let's take a look at negative numbers. What if I did negative 3 times, negative 3, or, excuse me, negative 3 squared? That will just still equal 9. A negative times a negative is a positive. So I want to get that idea through. A negative times a negative is still equal to a positive, because it's important to the idea of the imaginary unit. We're doing with the imaginary unit. Well, let me just go ahead and explain how we get to the imaginary unit. It's nothing really deep. We just take the, instead of, okay, let's, square root of 1 is just equal to 1. That's because 1 times 1, and let me just use a different color real quick. 1 times 1, oops, is equal to 1. And let me try and show you how I'm looking at it. And I'm going to actually go ahead and write 1 times 1 is equal to 1 squared, which is just equal to 1. And maybe it would have been better if I used a different number. And you know what? Let's go ahead and do that. Why not? The square root of a nice number, 4. Well, that's just going to equal 2. Well, that's because 2 times, and if you haven't seen that dot before, it's the same thing as writing that little tiny x for multiplying. 2 times 2 is equal to 2 squared, which is just equal to 4. Oops, I forgot my equal sign. And that's the idea I'm trying to communicate. What we're doing when we're square rooting, we're finding the number that multiplied by itself will equal the thing that's underneath the square root symbol. I don't know what you call it. I'm going to call it square root symbol for this video, though. Alright, so, and we already showed that if, oh, well, square root of 2, just as valid, the square root of negative 1 could, square root of 1 could also be negative 1. Because negative 1 times itself is just equal to 1. Square root of 4 could also be 2, or it could be negative 2. So that's another thing to pay, I guess, key attention to, because if you just take a look at the real numbers, and I'm just going to draw a number line. We call them the real numbers for some reason. I don't know why. If you ask me, any number is just as real as the next. So the idea of an imaginary number just seems funny to me, and I'm sure to a few others. 1, 2, negative 1, negative 2. Alright, so you go on any, you pick any number from the real number system, okay, pick any number from the real number system, and you multiply that number by itself, you'll get a positive number, whether it's negative, whether it's positive. Negative 2 times negative 2 will equal 4. Positive 2 times positive 2 will equal 4. And that's the idea I'm trying to communicate right now, because it's important to understand where the imaginary unit comes from. And the imaginary unit comes from the question, well, what if I just took, and I'm going to pick the simplest number that I or anyone else knows of, what if I ask what the, I don't remember how I set it up, I think red was under the square root symbol, but what if I asked you what the square root of negative 1 was? Well, I already showed you that any number, whether it's positive or negative, will give you a positive number when you multiply that number by itself. So what number times itself will equal negative 1? Well, we don't know of a number, so we just say that the square root of negative 1 is equal to this. When we make it up, it's just as made up, I guess, as the idea of number 1 is, or number 2 is, or number 3 is. But we just make up a number and we say negative 1, the square root of negative 1 is equal to I. Or you can alternatively think of this like this. If you say I times I, or another way to say that is I squared that's just equal to negative 1. Alright? Nothing really deep there. Maybe you find something a little bit deep there. If you do, that's cool. I mean, I just see it as it is, and that's what I see. I is just this made-up idea, or a tool, if you want to think of it that way. It's a tool that we use to do more math, basically. So it's a very important number, because we can now solve. And I'm not proving this to you. I guess you got to take it at face value, or just believe me. But we can use this number, this I number, to solve any algebraic problem. And it's important in the development of mathematics, and it's even used in. It's going to be used in my field, or it's not gonna. It is. It's used in my field, electrical engineering. I've been told it's used in water pumps, like if you're doing fluid dynamics, you got to use I. It's used in quantum mechanics. It's used in a lot of places, so it's very real. It's a very real thing, which is it's why I think it's a little bit of a misnomer to call it imaginary number or imaginary unit. Really, so that's the concept of an imaginary number right there. I can't see how much time I have left. Excuse me. Why not go for another bit, little bit of an idea? Okay, yeah. Here's another thing I can include. So I guess I was using. Well, I had a different system for that. That color system I just made up on the go. All right, so I'm gonna go ahead and just write this down. I, that's just equal to I, obviously. But I squared, that's equal to negative 1. Well, let's go ahead and show how that is. I times I is, by definition, equal to negative 1. I cubed is equal to I times I times I. Well, I'm going to go ahead and think of it like this. Let's just group these two together. I times I, as we've already shown over here, that's equal to negative 1. Well, negative 1 times I, that's just equal to negative I. I to the 4th, that's just equal to, well, getting ahead of myself, I times I times I times I. I'll group them like I did before. That's I times I, well, or I squared. I could write it I squared. I squared. Well, I squared is just negative 1. I squared is negative 1. Negative 1 times negative 1, that's just equal to 1. Nothing deep going on here. Just multiplying this made-up idea, I, by itself, and I'm getting these numbers. And if you do I to the 5th, you'll find that that equals I to the 6th, that equals negative 1, and you can see it repeats this pattern. I, negative 1, negative I, 1, I, negative 1, negative I, 1, and it'll just keep going like that forever as you increase the power. Okay, so that's pretty much that. Thinking if I have enough time. My screen's not turning on. It means the camera's still going because the light's blinking. Let's just keep going with it then. That was the concept of an imaginary unit. I multiplied it out. Alright, so a complex number. Basically, a complex number is, let's say I gave you the problem 2 plus I. And I told you to add them together and tell me what that's equal to. Well, 2 plus I is really just equal to 2 plus I. You can't really simplify it more, actually. I shouldn't say you can't really, you just can't. You can't simplify it more. That's just the way it is. Maybe if I gave you the problem I times 2I, then that would be, you distribute the I, you get 2I times I squared, plus I squared, and that would turn into, since we know that I squared is equal to -1, 2I minus 1. Some people don't like to write it that way. Some people like to write the real number first, -1 plus 2I. And that's really the idea of a complex number. You can't simplify them really. I did exponents, going from I squared, I cubed. Well, what if I went the other way and said, what if I said I to the -1? Well, that's just equal to 1 over I. Oh, we already talked about this idea of 1 also equaling I to the -4th over I. Okay, well, if I is -4, let's write this as kindergarten as we can. We'll do I times I times I times I, all divided by I. And really any number. So this is going to cancel out basically, and I'm assuming, well, I'll just go ahead and explain why it cancels, just in case somebody ever watches this and they're curious, but well, why not? Okay, so if I had 8 divided by 2, this is a different problem. Okay, if I had 8 divided by 2, well, that's like saying 2 times 2 times 2 divided by 2. Well, the 2's would cancel out, and you'd just be left with 2 times 2, and that would equal 4. The 2's cancel out because, well, if I have 1 over 1, that's equal to 1, of course. If I have 2 over 2, that's just equal to 1. 3 over 3, that's just equal to 1. Any number over any number is just equal to 1. So that means, in a roundabout way, I could think of this as 2 times 2 times 2 over 2. That 2 over 2 just turns into a 1. And really, I mean, I don't even have to include that in there because anything times 1's the anything. It's x times 1 is x. So that's why these i's cancel out, and you could alternatively write this as I to the 3rd, and even alternatively at that, you could write this as -I. As I showed earlier, I to the 3rd equals -I. And I can re-show that again, so I to the 3rd is just like saying I times I times I. I'll just group these two i's together. That's equal to -1 times I. Well, -1 times I can shorten that by just saying -I. Alright, so I think that covers the idea of imaginary units. I know there's some other stuff that I can include in here, but I just don't know how much time I got left, so I'm going to cut it off right here.